The story of our search for other worlds begins with a simple act. It starts when you step outside on a clear, dark night. You look up. You see the vast, velvet blackness dotted with countless points of light. Each one of those lights is a star, a distant sun. And for as long as we have been human, we have looked at that same sky and asked the same profound questions. Are we alone? Is there another world out there, somewhere in that immense darkness, that looks a little bit like our own? This is not just a scientific question. It is a deeply human one, born from our innate curiosity and our desire to find our place in the cosmos. This feeling of wonder is a powerful force. It has driven explorers across oceans and continents. Now it drives us to look beyond our own world, across the unimaginable emptiness of space. The night sky is a time machine. The light from the nearest stars has traveled for years to reach our eyes. The light from distant galaxies has traveled for millions, even billions of years. We are seeing them not as they are now, but as they were long ago. And as we gaze upon this cosmic history, we cannot help but wonder what futures are unfolding around those distant suns, right at this very moment. It is an instinct we all share. A child points to the moon and asks if we can go there. An astronomer points a telescope towards a faint star and asks if it has planets. The scale is different, but the spirit is the same. We are an inquisitive species. We want to know what lies over the next hill, beyond the next star. This drive is written into our DNA. It is the same impulse that led our ancestors to leave the safety of their caves and explore the world. Now, the entire universe is our wilderness, and we are just beginning to take our first tentative steps into it. This quest for a new Earth is more than just science fiction. It is a real and exciting part of modern science. It is a story about human ingenuity, about our ability to build incredible machines that can see across the galaxy. It is a story about our deepest hopes and our greatest challenges. As we stand on our small blue planet, looking out at the infinite expanse, we are not just searching for other worlds. We are searching for a deeper understanding of ourselves and our own precious home. The journey is just beginning, and the universe has so much more to show us. How do you find a planet that is trillions of kilometers away? A planet that is completely dark, lost in the brilliant glare of its parent star? It seems like an impossible task. But scientists are clever. They have devised ingenious methods to find these hidden worlds. One of the most successful methods is called the transit method. Imagine a moth flying in front of a bright streetlight. As it passes, it blocks a tiny fraction of the light. We see the light dim just for a moment. This is exactly what astronomers look for. They stare at a single star for a very long time, waiting for this telltale dip in brightness. These dips are incredibly small. For a planet the size of Earth passing in front of a star like our Sun, the brightness might drop by less than 1 part in 10,000. It is a minuscule change. To detect it, we need incredibly sensitive telescopes. Telescopes like NASA's Kepler Space Telescope and now the TESS mission. These amazing instruments are designed to stare at hundreds of thousands of stars at once. They measure their brightness with extraordinary precision, day after day, year after year. They are our planet-hunting machines, patiently waiting for a world to reveal its shadow. When a telescope detects a repeating dip in a star's light, it's a clue. It suggests that something is orbiting that star. By studying the pattern of these dips, we can learn a lot. We can figure out how long it takes for the planet to complete one orbit, which tells us its year. We can also estimate the size of the planet. A bigger planet will block more light, causing a deeper dip. It is like cosmic detective work. We are gathering clues from light that has traveled for hundreds of years, piecing together the story of a distant solar system we can never visit directly. This method has been spectacularly successful. Before these missions, we knew of only the planets in our own solar system. Now, we have confirmed the existence of thousands of exoplanets, planets orbiting other stars. The galaxy, it turns out, is teeming with worlds. We have found gas giants larger than Jupiter, orbiting incredibly close to their stars. we have found rocky super-Earths bigger and heavier than our own planet. And most excitingly, we have found planets that are roughly the same size as Earth. Each discovery is a new piece in a giant cosmic puzzle. Finding a planet is just the first step. The next question is, could it support life? What makes a planet Earth-like? It is a question with a complex answer, but we can start with a few key ingredients. The first, and perhaps most important, is liquid water. All life as we know it depends on water. It is a universal solvent, a medium for the chemical reactions that make life possible. So, when we look for another Earth, we are really looking for a world where liquid water could exist on its surface. This is the foundation of our search. For a planet to have liquid water, it needs to be in the Goldilocks zone. This is the region around a star where the temperature is just right, not too hot and not too cold. If a planet is too close to its star, any water would boil away into space. If it is too far, the water would freeze into solid ice. The Goldilocks zone is that perfect, habitable distance where oceans, lakes, and rivers could flow. The size and temperature of the star determine where this zone lies. For a small, cool star, it is very close. For a large, hot star, it is much farther out. But a planet needs more than just water and the right temperature. It needs an atmosphere. An atmosphere acts like a blanket. It traps heat, keeping the planet warm enough for liquid water. It also shields the surface from harmful radiation coming from the star and from space. Our own atmosphere protects us every single day. Without it, Earth would be a frozen, barren rock. An alien world would need a similar protective layer. Scientists can study the starlight that passes through a planet's atmosphere to look for the chemical signatures of gases like water vapor, oxygen, and methane. Finally, we think an Earth-like planet probably needs to be rocky, like Earth, Mars, and Venus. It needs a solid surface to stand on. Gas giants like Jupiter and Saturn are mostly made of gas and do not have a solid surface. The size of the planet also matters. If it's too small, its gravity won't be strong enough to hold onto an atmosphere. If it's too large, it might become a gas giant. So, the recipe for an Earth 2.0 is specific, a rocky planet about the size of Earth, orbiting in the Goldilocks zone of its star, with a protective atmosphere and the potential for liquid water. To find and study these distant worlds, we cannot rely on telescopes on the ground alone. Earth's atmosphere, which protects us, also blurs and distorts the light from stars. So, to get the clearest possible view, we must go to space. That is why space agencies like NASA, ESA, and others build incredible, advanced spacecraft. These are not the starships of science fiction that travel between stars. Instead, they are our robotic eyes in the sky, designed for one purpose: to explore the cosmos with a precision we could never achieve from the ground. These are our true starships of discovery. Consider the Hubble Space Telescope. For over 3 decades, it has orbited Earth, giving us some of the most iconic images of the universe. It has shown us the birth and death of stars, looked back to the dawn of time to see the first galaxies, and studied the atmospheres of exoplanets. Then there is the James Webb Space Telescope. It is a technological marvel, truly. Its giant golden mirror is designed to see the universe in infrared light, which allows it to peer through clouds of cosmic dust and see the faint heat from the most distant and ancient objects. It is the most powerful time machine ever built. These telescopes are feats of human engineering. They are built in ultra-clean rooms where engineers wear special suits to prevent even a single speck of dust from contaminating the sensitive mirrors and instruments. They are subjected to extreme tests, shaken violently, and exposed to intense temperatures to simulate the harsh conditions of a rocket launch and the vacuum of space. Every component, every wire, every line of code has to work perfectly. There is no mechanics garage in space. Once launched, these observatories must perform their complex tasks for years, even decades, all on their own. The technology that goes into these spacecraft is astounding. They have advanced cooling systems to keep their instruments at temperatures colder than anywhere on Earth. They have precise pointing systems that can hold a telescope steady on a target that is light years away. They have powerful transmitters to send vast amounts of data back to scientists on Earth. Each new telescope is a leap forward, building on the knowledge and experience of the ones that came before. They are a testament to what we can achieve when we work together to answer the biggest questions. They are our silent, robotic explorers on the cosmic ocean. For all the wonders our robotic explorers can show us, there is something truly special about sending humans into space. It changes our perspective. Astronauts who have experienced spaceflight often struggle to describe the feeling. One of the most profound experiences is weightlessness. On Earth, gravity is a constant, unnoticed force, always pulling us down. In orbit, that pull is balanced by the speed of the spacecraft. The result is a sensation of floating, of being completely free. It is a feeling that has been described as a graceful, continuous dance with the cosmos itself. Imagine waking up and not being in a bed, but floating inside a sleeping bag attached to a wall. You push off a surface with your fingertips and glide effortlessly across the room. Eating, drinking, and working all become new challenges and new adventures. A drop of water does not fall. It forms a perfect, shimmering sphere that floats in the air. It is a world where the familiar rules of up and down no longer apply. This physical freedom is matched by a profound shift in perception. Astronauts are no longer just looking at the sky, they are in it. The journey itself is a symphony of controlled power. The launch is a moment of intense vibration and immense force, as millions of pounds of thrust push the astronauts away from Earth's gravity. It is a violent, exhilarating ride that lasts only a few minutes. And then suddenly, silence. The engines cut off, and the feeling of being pushed back in your seat is replaced by the gentle freedom of zero gravity. The astronauts are now in orbit, traveling at over 28,000 kilometers per hour, circling the entire planet every 90 minutes. From their perch on the International Space Station, a magnificent orbiting laboratory, astronauts have a unique relationship with our planet. They see 16 sunrises and 16 sunsets every single day. They watch lightning storms flicker silently over continents and see hurricanes swirl like giant white whirlpools in the blue oceans. They become intimately familiar with the geography of our world, not as lines on a map, but as a living, breathing entity. This experience of floating in the quiet of space while watching our bustling world spin below changes a person forever. It gives them a new appreciation for the fragility and beauty of home. What do you see when you look out of the window of a spacecraft? You see a view that has humbled and inspired every human who has witnessed it. You see our planet, Earth. It hangs in the black void like a beautiful blue marble. Swirling white clouds are painted over deep blue oceans and continents of brown and green. At night, the cities sparkle like clusters of diamonds, tracing the outlines of human civilization. There are no borders, no divisions, just one single unified home for all of humanity. Astronauts call this the overview effect, a powerful feeling of connection to our planet and to each other. But if you turn your gaze away from Earth, the view is just as spectacular. You see the universe in its raw, unfiltered glory. The stars do not twinkle as they do on Earth. The atmosphere that causes that twinkling is gone. Instead, the stars are perfect, brilliant points of light, shining with a steady, intense fire. There are more of them than you could ever imagine seeing from the ground. The Milky Way is not a faint, hazy band. It is a brilliant, dense river of stars that stretches across the entire sky, so bright it seems you could almost reach out and touch it. And nestled among the stars are the cosmic clouds, the nebulae. These are the birthplaces and graveyards of stars. Through the spacecraft window, you can see them in their breathtaking beauty. The Orion Nebula is a vast, colourful nursery where new stars are being born, glowing with pinks and purples. The Eagle Nebula's pillars of creation are majestic columns of gas and dust, silhouetted against the light of young, hot stars. These are structures so vast they are difficult to comprehend, places of unimaginable beauty and power, all visible from your tiny window on the cosmos. Looking out at this scene, you are confronted with the sheer scale and emptiness of space. The distances are immense, almost beyond human imagination. The planets of our own solar system appear as bright, wandering stars. Mars is a steady, reddish point of light. Jupiter is a brilliant beacon. But beyond them, there is just the blackness, dotted with the light of suns that are light years away. It is a humbling view. It reminds you of how small and fragile we are, but also how privileged we are to be able to witness this cosmic spectacle. It is a window to infinity. The search for a second Earth is one of the greatest challenges humanity has ever undertaken. The obstacles are immense. The nearest star to our Sun, Proxima Centauri, is over 4 light-years away. With our current technology, it would take a spacecraft tens of thousands of years to make that journey. We are searching for planets we can never hope to visit, at least not in our lifetimes. We are like ancient mariners, charting distant shores that we know we will never set foot on ourselves. It is a task that requires patience, dedication, and a belief in the future. Even if we find a perfect Earth 2.0, the challenges do not end there. How would we get there? Would we send robotic probes first? Or would we build vast generation ships to carry humans across the interstellar void, with generations being born and living their entire lives on the journey? These are questions that feel like science fiction today, but our descendants may one day have to answer them. The search for other worlds forces us to dream big, to think on timescales that span centuries, and to confront the ultimate limits of our technology and our biology. Despite these challenges, there is an undeniable sense of hope. Every new exoplanet discovered, every new piece of data from the James Webb Telescope, brings us one step closer to answering that fundamental question. Are we alone? To find evidence of life, even simple microbial life, on another world would be the most profound discovery in the history of science. It would change everything. It would reshape our understanding of our place in the universe. It would tell us that life is not a unique miracle of Earth, but a common cosmic phenomenon. That hope is what fuels the search. But this grand quest also teaches us a vital lesson. As we look out across the galaxy for another home, it makes us appreciate our own planet even more. Earth is not just a good planet, it is a perfect planet for us. It is the only home we have. The search for Earth 2.0 is a mirror. It reflects back on us the incredible rarity and beauty of our own world. The spirit of exploration that drives us to the stars must also drive us to protect and cherish the precious jewel we are already standing on. Our greatest adventure may be in the stars, but our most important responsibility is right here, at home,